Okay, so I'm going to do 2.4s, a couple of problems, 1, 2, and 3. So the way this works is they're asking you a couple of things. And what they're really asking you here to look at is, can you rewrite these things? And so the big thing that whenever they're telling you about this is they want you to be comfortable with the fact that there's things that happen and they'll look different, but in reality, they'll be exactly the same. So factored form, so what factored form means is the word factor means something times something, something times something, okay? And the simplified expression is like, once I write it in factored form, you're gonna understand like, oh, that they want me to simplify that part, yeah. So here you're going to take out the greatest common factor. So here you're looking for what number do you see in both terms. So I see a 7 here and a 7 times 0.675 here. So I'm going to factor out a 7. So the way I factor it out is I put the 7 on the outside and I put a big parentheses and I see what is missing in that parentheses. What is missing in that parentheses? So I say, okay, if I want to go back to over here, then I say 7 times what would give me 7. So that's just 1. And 7 times what would give me 7 times 0.675. So that's just 0.675. Oops, I have to squeeze them in there. Okay, so then they want you to simplify. Well, what part do they want me to simplify, Ms. Johnson? The part inside the parentheses. So here is 7 parentheses 1.675. That's all they wanted me to do. Yep. So the big deal here, and you'll see it in a little bit as we are writing it out, getting to this next couple problems here, is they want you to understand how to factor these things out, okay, and what they actually mean, okay. So if you continue on, this would be 19, and this would be 1 plus 0.33, and this would be 19 times 1.33, okay. And then you would continue on. Number 2 says, Jackson had invested $500 in an excellent money market account that earns 20% per year. That's a lot of money. That's a good percentage. Given is a chart of his year-end balances that appeared on his investment statements. 500, 600, 720, 864. So Jackson's money is growing exponentially, and he recalls from a previous math class that the formula of exponential function is y equals to a times b to the x. He recalls that a equals 500 and x is the number of years, but he thinks b should be 20%, but the number isn't giving him the numbers on the bank statement. What number should it be using for b, for example? Using b. So like what does that mean, Ms. Johnson? What are they saying here? Okay, so he thinks that it should be 0.2 as my b. So let's just like look at some of those numbers, and I'll build a table because then that's just easier to compare. So here we're going to use the numbers 1, 2, 3, right? And then here we're going to say, instead of this, I'm going to go a times b to the x. Well, a they said is 500, so that's 500 times b, which he thinks is 0.2, 0.2, and then to the x, not z, sorry, x, right? But then this equation, Desmos is mad at me because it's like, what are you talking about? So if you hover over it, it says too many variables, try defining x. Well, I don't want it to be x. I actually want it to be x sub 1. So I type 1 and then it's happy, right? So then it gives me 1 is 100, 2 is 20, and 3 is 4. Like, wait, what? So this is not it at all. So imagine you put $500 into your bank account. You put $500 into your bank account, right? And then at the end of the year, it said $100. Wouldn't you be like, what? Right, I would be like, what? I'd be like, what are you talking about? Okay, so what ends up happening here is the reason why this is wrong is because he's not taking account into the original balance, their beginning balance, which is why they had you do this first, right? So what they're failing to do is they're failing to add that original balance back in there. So if you notice, it shouldn't just be 0.675, it should be 1.675. So Ms. Johnson, you want me to change this to a 1 right here? Yeah, let's change this to a 1. And now you can see that those numbers are starting to match, right? Everyone see that? Okay, so that makes sense. Okay, so is that okay? Okay, let's try this next one. It says Jackie owes $500 on a loan. Okay, so she's owing money. So she has agreed to pay the loan company 8% of the outstanding balances on the first day of each month. Given is a chart of the balance that she owes after each payment. So notice here, the number is going down. But when she, again, same exact thing. So what number are we going to actually use here? And it's not going to be your 1.2, okay? Because it is decreasing, right? Because it is decreasing, we cannot put 0.8 here, or sorry, 0.08. We can't put 0.08 here. That's not going to help you. But if you notice, that 40 is the 40 that was decreased by. It decreased, right? So here, this is actually going to be, I'm going to put parentheses on it, 1 minus 0.8 to the x. And then my numbers start matching perfectly. So wait, Ms. Johnson, for the other one, you added 1 together? Yeah, because this is increasing, right? My balance is increasing. And here you subtracted from 1? Yes, because it's decreasing. Decreasing. Hopefully that makes sense.